Now we're going to look at the quotient rule, which, similar to the product rule, allows us to calculate a more complicated derivative here. So the quotient rule is something that we're going to use when we have a function of the form h of x is equal to f of x divided by g of x. So when there's a quotient involved. And examples of that might be sine of x over cosine of x, or e to the x over ln of x, or something like a polynomial of x to the fifth plus x to the fourth minus x squared over x cubed plus 3x squared, etc., etc. You get the idea of quotient. And the rule is if you have h of x equals to f of x divided by g of x, then h prime of x should equal the thing on the bottom, so g of x, times the derivative of the thing on the top, minus the thing on the top, the function on the top, times the derivative of the function on the bottom, all divided by the function that was on the bottom, still on the bottom, squared. So this right here is your quotient rule. Let's look at proving that, and we're going to do the same thing that we did before of plugging it into our limit definition and just working some fancy algebra to clean it up. So you don't need to write this down as we did before, but I do want you to kind of watch through and track and see if the proof makes sense. So we're going to start by plugging it in. So we have f of x plus delta x over g of x plus delta x minus f of x over g of x, all divided by delta x. That's just straight up plugging it into our initial setup. And now we're going to kind of clean that up a little bit, make it easier to work with by rearranging it. So I'm going to pull the 1 over delta x out front, and then I'm going to look for a common denominator of the numerator fractions, and that's going to give me the following: f of x plus delta x. Sorry, let me erase that. So f of x plus delta x times g of x minus f of x times g of x plus delta x, all divided by g of x plus delta x times g of x. And you'll notice that now this bit that I've got in the parentheses right here is the same as the numerator we had before. I just found a common denominator and combined them. Now, like before, we're going to add, or like with the product rule, we're going to add and subtract a term in here that will let us break things up and work with it in a little bit nicer of a way later. So we've got our f of x plus delta x times g of x, and then I'm going to subtract and add f of x times g of x. So I'm subtracting it, then I will also add it, f of x, g of x, so that this bit right here is just equal to 0. I haven't changed my function at all, or my expression. G of x plus delta x, and then this is still all over g of x plus delta x times g of x. So I haven't changed the value of this. I've just rearranged things a bit. And then now we're going to swap our denominators here on the two fractions just so that we can do something later that will make sense when we do it later. So we're going to pull out 1 over g of x plus delta x, g of x. And what I'm going to do right here is split it and factor at the same time. So I'm going to take these first two terms here and I'm going to pull out a g of x. So g of x times what's left over is f of x plus delta x minus f of x, and all over delta x. And then in the second term, I'm going to get a similar thing, but it's going to be f of x and g of x plus delta x minus g of x over delta x. So I did a lot of algebra right here to get to this step, just so I don't have to write as much to show you later. But basically what I did is first I switched the delta x and the g of x plus delta x. That's why you can see inside the brackets, we've got these delta x's in the numerators or denominators, and outside the brackets, I've got this g of x times g of x plus delta x. Then I took these first two terms here. That highlighting is really hard to see, but I took these first two terms here and I factored out the g of x. But you can kind of see what I've done here. I factored out g of x, so that left me with f of x plus delta x minus f of x in the numerator and the g of x out front. Then I had these second two terms here, so this term and this term, and I factored out a negative f of x right here. So by factoring out the negative f of x, I was left with the g of x plus delta x minus the g of x from this one right here. Now let's go in and apply our limit expression. So the limit on this first set of terms, if delta x is approaching 0, I'm left with just g of x. So I get 1 over g of x squared. Then inside the brackets, well, if I apply limit as delta x approaches 0 to g of x, nothing happens. So I just get g of x again. But now we've got this f of x plus delta x minus f of x over delta x. And that's just the derivative of f of x. So we've got that. Then the second part, f of x doesn't get affected by taking the limit as delta x approaches 0. And then this part in parentheses right here is just the limit definition of the derivative of g of x. So I get g prime of x as well. And then if you look back, you'll notice that this is just a slightly different way of writing what we had before, where it's 1 over g of x squared times the quantity in the numerator as opposed to divided, but we've essentially sufficiently proven it here. So let's look at some examples. Cosine of x divided by e of x, well then our derivative is just going to be the thing in the denominator, so e to the x times the derivative of the thing in the numerator, negative sine of x, minus the thing in the numerator, so cosine of x, times the derivative of the thing in the denominator. So that would be e to the x, all divided by what's in the denominator, so e to the x squared. If we want to clean that up a little bit, that will be one of the e's to the x can cancel from everywhere, and we'll get negative sine of x minus cosine of x over e to the x. And then a second example, I'm going to show the one that we did in the product rule, but I'm going to do it as a quotient this time. So g prime of x will equal the thing in the denominator, so x, times the derivative of the thing in the numerator, which is 1 over x, minus the numerator, which is ln of x, times the derivative of the denominator, which is just going to be 1, all over the denominator, which is x squared, and that will give us 1 minus ln of x over x squared. So you can go back and check the product rule and see that we have the same result here.